This is the notes for section 7/6, nth root. If you haven't done so already, please make sure you pause the video at this time and read the section before continuing on. First of all, we're going to define the nth root of x, and we say that n, if we let n be an integer greater than 1, okay, then b is the nth root of x. Okay. B is the nth root of x if and only if b to the n is equal to x. So if we have a number that we can raise to the nth power and get x, we say that that number b is the nth root of x. Okay? So if I look at these examples here, since 3 to the 4th power is equal to 81, 3 is a 4th root of 81. Since negative 2 to the 5th power is equal to negative 32, we can say that negative 2 is a 5th root of negative 32. So whatever number we can raise to the nth power to get the number that we're looking at, we say that that number is the nth root of the number that we're looking at. Okay? So let's take a look at this example here. It says solving the nth roots using graphs. Find the real 8th root of 3 by graphing. Okay. Well, if we're going to graph our solution to do that, okay, we can use our graphing calculator, and what we're going to do is we're going to graph x to the 8th, and we're going to graph the line y equals 3. So we're going to graph those two equations on our graphing calculator, and then we're going to find the intersection point. Okay, where those two intersect, those two values would represent the nth root of x, or in this case, the 8th root of 3. So positive and negative 1.1472 represent the two real 8th roots of 3. Alright, let's take a look at the 1 over n exponent theorem, and here's what it says. It says when x is greater than or equal to 0, and n is an integer greater than 1, then x to the 1 over n is the nth root of x. A couple key things here. First of all, the value of x, that base, has to be a positive number or a non-negative number. It's got to be greater than or equal to 0. And the value of n, the number on the bottom, has to be an integer greater than 1. Okay? So 1 over 2, 1 over 3, 1 over 4, etc. Because of this, we say that x to the 1 over n stands for the unique non-negative real nth root of x. Therefore, x to the 1 over n is always a value that is a positive or non-negative value. So 8 to the 1/3 is equal to 2. Okay? Because if I take 2 times 2 times 2, I get 8. Now, negative 8 to the 1/3 is undefined, because the only number that I can raise to the 1/3 power and get negative 8 is negative 2. However, I know that 1 over n is only defined when x is greater than or equal to 0, and negative 2 is not greater than or equal to 0, therefore it's undefined. Okay, so the number of real roots theorem says the following, that every positive number has 2 real nth roots when n is even. Okay, so here's a graph of an even power function right over here. Okay, you'll notice that if we have a positive number, this horizontal line, it intersects the graph in 2 places, and that's why there would be 2 real nth roots when it's a positive number and an even function. Okay. Now, if it's a positive number and an odd function, it's only going to have 1 real nth root, because here's an odd power function and what that's going to look like. And you'll notice that a positive number will only intersect that 1 time. Okay? When I look at a negative number, okay, these horizontal lines here down underneath, okay, if I have an even power function, there's not going to be any real nth roots of that number. And if I have a odd value of n, there will be one real nth root of that number. And then finally, 0 always has one real nth root. So let's take a look at example 1 here. It says approximate the real sixth roots of 3 by graphing. Well, to do that, we're going to graph two functions, y equals x to the sixth and y equals 3, and then we're going to find the intersection points of those two functions. So on your graphing calculator, why don't you do that at this time? Graph those two functions and then find the intersection points. Okay, so as you can see here, I've graphed those two functions, and there's two intersection points, therefore there's going to be two real sixth roots of 3. Now we want to find what those values are. To do that, we're going to go to Menu, and then we're going to go to Analyze Graph, and we're going to look for the intersection. And then we can set a lower and upper bound. Just drag across, and once we do that, it will bring up what that point is approximately. Okay, so we've got one point at negative 1.23, and let's do it again and find the second point. Exact same thing. Pick a lower bound to the left of it and an upper bound to the right of it, and it will give us that second point. Now, it's not exactly 1.2. That's been rounded off. We could change our attributes on that and see that it's something very close to 1.2. But what we're saying is the third root, or the sixth root of 3 is negative 1.2 and 1.2. So let's take a look at example 2 here. It says approximate all the real solutions to x to the fourth equals 100 to the nearest thousands. Well, we know because 100 is a positive number, and because the value of n is 4, which is an even number, that there are two real fourth roots of 100. Okay, and those two real fourth roots of 100 are 100 raised to the 1/4 power and the opposite of 100 raised to the 1/4 power. Okay, so to find those, we can put those into our calculator. So I'm going to enter 100, and then I'm going to raise it to the 1/4 power. So I'm going to go with my arrow up to raise it to the to get a power, and then you can hit Control and then divide, and you'll get your fraction key. So we got 1/4 there. And then if I hit enter, it gives me that. Well, I don't want that. I want Control Enter, because if I hit Control Enter, it will give me the decimal approximation, which is what I'm looking for. So I know it's about 3.16228. Now it asks for our answer, the nearest thousandths, so that would be 3.162 rounded to the nearest thousandths. And then we also know it's the opposite of that, which would be negative 3.162. Okay, I'd like you to see if you can answer 3 through 6, the remaining problems that are here. See what you can do with those, and then I want to look at those in class next time and see if we can answer any questions that you might have, and maybe have a little bit of discussion about numbers 3 through 6.